So with having worked first with Dynas cubes perhaps a little bit, I think it's good to move to the Cuisiner rods, especially with the small numbers. And of course one of the first exercises you can make children do is they can do different patterns with it and know that each of the numbers represents so many blocks, right? So if you had 2 blocks, it will fit neatly on a Cuisiner rod of 2. So this gives children a sense of color, and I think they enjoy the color as well. So they'll associate a number with a color, and you can then use it for addition. So for small numbers, let's say you take a number, this is 6, and then you can see what are the cubes that you can use to construct 6. So of course one possibility is this, but also you can just have 2 3s. So if you add 3 plus 3, what will you get? And then you can also have one in which you start with a 6 and then see what are all the patterns that add up to a 6. So you can say, okay, if you have 2, then 2 and 4 will also add up to 6. It doesn't have to be this. You can start with the equal ones and then you can say, okay, 2 and 4 add up to 6. Then 1 and 5 will add up to 6. So these patterns for different numbers can be made, and this can make children aware that there are different combinations with which you can get the number 6. Yeah, and these are the only 3 combinations, 1, 2 and 3. 3, it becomes equal. Then again it will be 3, 4 and 5. But the combinations are 1 plus 5, 2 plus 4, 3 plus 3. All of them are 6. Then another kind of game you can start is that you can have 3 and then you can say, okay, what can I add to 3 and what will I get, right? So if I say, okay, if I add 3 plus 4, what will I get? And children can get some sense of the length, and they should be able to start predicting what length I can put here in order to match. So for example, if they had options, and if they go too far, right, then they'll know that, okay, I went too far, right? So if I put an 8, that doesn't work. And children will get a sense of the length and say, okay, that looks as long as 7. So for numbers up to 10, the addition of small numbers that add up to 10, the Cuisiner rods are quite visual and a very good way of getting both a sense of distance. So this is the length of 7 centimeters. So getting a sense of distance as well as getting a sense of what the addition of the numbers would be like. So they can also be used to figure out how many rods are needed to get 10. So to get this sort of round number when you're adding something, which is very useful later on. So if they take something like a 5, then another 5 is needed to get to 10. Right? If they take something that's like a 7, then once the children put it, they can see that it's as big as a 3. So even if they didn't know that 7 plus 3 is 10, this gives them a sense of what needs to be added, especially beyond 5, what number needs to be added to get to a 10, which is useful when you're doing, like if you want to add a number to 8, if you want to add a number to 6, if you want to add a number to 7, then getting a sense of what it takes to get to 10 can be quite useful, because if you say, okay, 8 is an 8, 8 plus 6 will be what? So then you know that if I can write 6 as 2 plus 4, 2 plus 4 is 6, then the 2 will get it to 10 and you'll get a 14. So that's later, but right now you basically focus on numbers up to 10 in this. Numbers beyond 10, it's better to use a Ganit track. So a lot of patterns can be made with these. They are colorful rods, and we should make patterns with the idea of what does it add up to. And so this is one set of things we can do with the Cuisiner rods. The other thing that can be done with the Cuisiner rods is multiples. For example, you see that you can fit 3 3s and 9, right, or 2 3s and 6. And you can fit 2 4s and 8. So all these patterns also are quite nice for children to explore and get a sense of, they are also getting a sense of fractions. So they are saying that in a 9 there are 3 3s, or 3 is 1/3 of a 9. So these are also concepts that can be brought in depending on what kind of pattern children come up with when they have the cubes. So the goal is to help them explore different kinds of patterns. Say what all numbers can you get with threes? How many parts, how many threes can you fit into 9? Right? How many twos can you fit? You can just take a number at random and say, okay, this is what I have. How many threes can fit into this, and can threes fit into this? And the children have to remember, of course, what the number is, right? And so when you put those and you say, okay, there's actually, you can't fit twos exactly in a 7, and what numbers can you fit twos in? So you can get a 6, you can get a 4, you can get a 2, you can get an 8. So these patterns also can be explored. All the number patterns that are interesting can below 10. It is a very nice set of material to explore it with. If you are using Dynamic cubes for addition, then Cuisiner rods are very good to do the ones place. You don't use it for the tens place, but if you use the ones, they take a long time to do the addition with the Dynamic cubes. So instead of that, you can use the Cuisiner rods. Yeah. So these are some of the ways in which these rods can be used. So one, to get a sense of numbers, to get a sense of addition of small numbers, to get a sense of how many of something I can fit into the other, so that's like fractions or multiples, to get a sense of odd and even. These are the different things we can do with the Cuisiner rods. And also to be used as a ones place when I'm doing addition with material. You can use this as a ones place, so the addition is much faster.